So in this video we're going to solve a quadratic equation by completing the square in a case where we get complex numbers for our solutions. So our solutions will involve the complex unit I. So solve this equation by completing the square and using the square root property. So we rewrite the equation. Negative 4x squared plus 6x minus 5 equals 0. Again, I like to get the constant terms over on the right, so I'm going to add 5 to both sides. And that's going to leave me with minus 4x squared plus 6x on the left-hand side. We want to be careful to remember that the completing the square process requires that the leading coefficient on the x squared term is a 1. So right now I see a negative 4. And I need to get a 1, so I'm going to divide both sides by negative 4. So I'm going to divide everything on the left-hand side by negative 4 and everything on the right-hand side by negative 4. So this is going to be a negative 5/4. And negative 4 divided by negative 4 is 1x squared. And I have a positive divided by a negative is going to be a negative, and 6/4 simplifies to 3/2 of an x. And then I want to remember that my next step is to take half of the coefficient on the x term and then square it. So I'm going to take the negative 3/2, which is the coefficient on the x term. I'm going to have it by multiplying by a half, which is going to be easier than dividing by 2, which would give me a complex fraction. Once I have it, I need to square it. So negative 3/2 times a half is negative 3/4. Negative 3/4 is a number that will be squared to complete the square. And negative 3 squared is 9, and 4 squared is 16. So 9/16 is what I need to add to both sides, so that I have completed the square on the left-hand side. So plus 9/16. Whatever I do on one side, I added 9/16 to complete the square on the left side, so I need to add 9/16 on the right. Negative 5/4 plus 9/16 will require a common denominator of 16, so I would multiply negative 5/4 by 4 over 4, and that's going to give me negative 20 plus 9 is negative 11 over the common denominator of 16. Maybe give myself a little room here. Negative 11 over the 16. I know I'm going to need to take a square root, so I might as well leave the room for it. I completed the square. Whose square did I complete? Well, it's always going to be x, because x squared is x squared. And then what number did I square to get the 9/16? Well, I squared a negative 3/4, so I'm going to get minus 3/4. This right here should always be half of whatever this middle coefficient was. So I took half of negative 3/2. I got negative 3/4. It's a minus 3/4 that's going in here. Now I can see that I'm in a position to use the square root property. So I'll take the square root of the left-hand side to kill the squaring here. And whatever I do on one side, I do on the other. And I immediately put my plus or minus because there are two possible solutions. So equals plus or minus. Here I see I have the square root of a negative. That means this is a complex number right here. So I can immediately pull the I out like we did in the videos for complex numbers. So that I comes out of the square root symbol. It's not in there anymore. That's what removes the square root of negative 1. And then over here the square root cancels the squaring. So I'm going to get an x minus 3/4. And then I'm going to need to do a couple things here. I'm going to need to add 3/4 to both sides. So there's going to be a 3/4 here. There's going to be a plus or minus, and then I need to put this into simplified radical form. The square root of 11 is already as simplified as I can get it, but in the denominator position I have a square root of 16, which is 4. So I need to simplify that, and times the I. The midpoint on the I is in line with the fraction bar. And here I have my two solutions. If I wanted to put them in set notation, I could say x is an element of the interval that contains, let's see, it's 3/4 plus the square root of 11 over 4 times I, comma, and the other one is 3/4 minus, and we get square root of 11 over 4 times I. That 11's not very good. And you could write these over the common denominator. So another way we could do this if we wanted to, we could say it's going to be 3 plus. We could do this. We probably shouldn't, because we're going to make a mistake with the I if we do. So let's leave it like this, and not make things likely to get us in trouble. So anyways, this is completing the square when we get a complex solution.